Welcome to the new video. Here in this particular video we are going to see about Docker image. What is Docker image and what are the layers in it and how exactly it works, what is the layers behind that, how the building was done, how the versioning and tagging is done, how the registries and sharing will be done, the images, and some practical example and some interview tips also. Okay, without further ado, let's enter into the video. First of all, Dockerfile. If you see the official definition, a Dockerfile is a lightweight standalone package that contains everything needs to run a application. Okay, remember, lightweight and standalone package. Okay, basically lightweight means it have a less size, and standalone it maintains some isolation. Basically it includes code, its runtime, libraries, enrollment variables, and configuration files and dependencies. Like whatever exactly the application requires to run properly, only those things are available in this particular container. Okay. Sorry, in this particular image we are not dealing about the container will come in later. Okay, and these images are read-only templates which is used to create a containers. Based on these images the containers will be created, and this is like foundation of containerization and modern DevOps workflow. If you see the key benefits, consistent environment across the development, testing, and production. Why? Because the package will be the same, right? So that will be shared among the team, and in the development, testing, and production, the same thing will be flown. And there is a faster deployment and scaling. This is so one of the key benefit, and it will obviously improve the resource utilization. That is the one of the key thing. And if you see the like what exactly the Docker image in a non-technical example, it is just like a architectural blueprint. Okay, where contains all the instructions to build a house. Here a Docker image is contains all the instructions and components needed to create a container. Okay, if you see a house blueprint was the image, and what exactly the actual house, that is the container. Okay, and then it basically follows kind of a layered structure. If you see here, the base image has a multiple layers. Okay, foundation layer. Okay, and application layer, read only templates, efficient storage, incremental updates. Okay, we'll discuss about this one by one. Okay, so basically the base layer is like foundation layer which we are going to use in the Docker file. Whenever we are writing a Docker file, we used to write from Ubuntu, like that. So Ubuntu, basically here Ubuntu will be the base layer, which on top of that whatever the commands you are running, that will be built and that will be worked on that particular image only. That is the purpose of the base layer here. Okay, so application layer, after that application layer will come into picture, where each command in Docker file creates a new layer, and like whatever you write, this is a base image, base layer. Okay, Ubuntu, and install Java runtime, this is a application layer. Install dependencies, this is also one of the layer in the application level. Okay, and these layers are immutable once created. Okay, we cannot change the layers, that is the one key point here. So because of that, we need to, while writing the Docker file itself, we need to maintain a cache. Okay, we need to, as much as possible, we need to reduce the layers in a Docker file. Okay, uh, and also efficient storage, layers are shared between the images. Okay, so as I said, like I think I haven't covered that. Basically, each layer builds on top of the previous layer. Okay, so here maybe that are interdependent. Okay, one should run after the next layer, that layer only. So that is the uh, like how the layers follow. Okay, that is how they follow they manage the efficient storage. And coming to the incremental updates, only changed layers need to be downloaded. Let's say if you build a image, okay, so whatever the, let's say if you again build a image, okay, you make some changes in the code and you again build a image. Basically if you uh, maintain this incremental updates, basically that will allows to not to rebuild it again. Okay, that is the one thing. um, Here if you see why exactly the layers matter, if you update your application code, only the top layer needs to be rebuilt and redistributed, not the entire image. Okay, that is the actually the incremental updates. Okay, and these are the like layers actually. Kind of example. Okay, so base image, and then we are installing the run dependencies and runtime, and we are copying the actual application code, and we are maintaining the environment variables, and we are starting the application. Okay, so this is a kind of layered stack example. Okay, and now coming to the building images, how exactly the images are building. So basically docker file, some basics we need to discuss here. So docker file is like a text file with all the instructions to build an image, right? So whatever the commands, each line will create a new layer as we discussed in the earlier. So whenever the new like command will be triggered, on top of that new layer will be created. So if you see the build process, docker reads docker file top to bottom. Whenever if you see a example here, from it is like base image, obviously base image is required to run the different commands. Why? Because on top of the base image only all these commands are running. If you run this part current like set the working directory as slash app, basically it was making within your image, that is node, which is obviously a Debian image. So it was setting your working directory as app, and then you are copying the like whatever the package is required, and then you are installing the npm install, like whatever the dependencies we can say, and then we are copying the source code, and then you are exposing the port 3000 to a container, that means in this particular image. Okay, and then we are starting the application. Okay, so if you see, these are like following from top to bottom. Okay, so the best practice is order commands by frequency of change. Okay, so basically what exactly this best practice was, order commands by frequency of change. Okay, whenever there is a change in the code, we need to build it again. Okay, and I will show the commands also to build. These are the commands like common build commands: docker build hyphen t my app. Basically this is your application. Okay, you are giving a tag actually. Okay, your image tag should be this. Okay, and this is the command docker build hyphen t and your tag, and space dot, basically space dot will says you are in a current directory, the docker file is also in a current directory. So build your docker file and tag that docker. Once the docker file is created, image will be created, right? So once you docker, I mean with the help of docker file only you are building it, right? So once you trigger this command, what exactly it does, it will follows this sequence of steps. Okay, from top to bottom. Okay, so you can run in the terminal also, interactive terminal. If you run in background, it will run in backend. If you run the command same exactly like this, then the commands will be executed, and you can see like what exactly it's happening from working directory setting up. In the third step, it was copying the packages. In the fourth step, it was running. It was installing the dependencies. In the fifth step, it was copying the source code. Like that, you can see interactively in the terminal itself. And the one more common build command was docker build -t, and your like a tag, and then hyphen no cache. Basically no cache in the sense, um, let's say if there is any change in the code, okay, so if you set up no cache, then it will restart from the beginning. Okay, let's say if you use this particular first command for first time, and then when you try to rebuild the image, already you have certain image, certain image, correct? You already build this all the steps, and then you are rebuilding this as a second step. In between this first step and second step, what you did, you changed your some source code. Okay, and then you are building this particular code. So already you have a certain steps already installed and created, installed dependencies, everything. If you use hyphen no cache, it will restart from fresh. Okay, from step 1 it will again start restarting. If you don't use that, already the dependencies, all everything is there, it will just update your code like that it will be. Okay, and here as I said, the dot tells docker to look for docker file in your current directory. Okay, and here there is also one more point, layer optimization. Dependencies are copied and installed before the application code. Okay, for enabling a layer cache. Basically layer cache is nothing but, let's say if you are copying the package.json where you have a requirements, okay, like what are all the dependencies is there in that. Okay, once after you getting your dependencies, what you need to do, you need to install those dependencies. So what exactly here happening, if you compare these two steps, it was using before, like what exactly it was done in the earlier step. That means it was utilizing earlier step, that means cache is implemented there. Okay, so that is the purpose here of reusability, where layers in the image will be reduced. Okay, and coming to the versioning and tagging. Okay, in docker, there is a version, I mean in docker images there is a concept of versioning and tagging. Okay, first we will discuss about versioning, and then we will discuss about tagging. Okay, basically, um, basically if you see here, tags. Okay, these are the like tagging. What is, what are tagging? Okay, human readable labels for image versioning. Okay, whenever you create one new image, there will be a kind of a tag will be given where you are able to understand, and whenever you need, or whenever you wanted to share, you can share that particular tag. Okay, and the format will be like this: repository and tag name. Okay, in between colon. Okay, example you can see nginx 1.21 like that. And default tag, let's say if you don't use any tag, then by defaultly the latest will be applied. Okay, and multiple tags also you can give for the same image. And best practice, you need to follow a semantic versioning. Basically semantic versioning is something like giving version 1.2.3 like that. Okay, so basically here one is like major. Okay, basically major in the sense like what is the like mm, major change or major application. Okay, if something major happening in the application wide, then you are going to change this 1 to 2 like that. Okay, and this is minor, some new feature is added in the code like that. And this is like fixes. Okay, so let's say if there is any bugs found, or some critical vulnerability was found, in that case you will change the image, right? So at that time you need to change this particular version. This is the sequence how it was followed. Okay, 1.1.1 like that we can say. Okay, here you can see the semantic example. Okay, v 1.2.3, v 2.1, these are all examples for semantic versioning. And also environment, like you can, I mean, these are the tagging suggestions actually. Okay, uh, you can give dev, staging, production like that, and some future or the hotfix security like that. And also you can give your timestamp like 2025 115 like that. Okay, and uh, here are the some example tags. Okay, you can, if you don't use anything, by defaultly the latest will be taken. And here is one semantic tag example, nginx 1.21, my app v2.1.0, my dev. Here like environment is used, here semantic versioning is used, and redis 6 alpine. Okay, and in the production, whenever you are using any like images, don't use latest tag. Okay, so basically it will break your application when the image is updated. Okay, that is the key point here. You need to understand how exactly and why exactly it will breaks. Okay, why? Because as I said earlier also, if you don't give any tag, by defaultly it will take let's say if you don't give any tag here. Okay, so you just give a image name, tag is not given, this is not there. Okay, so if you don't give, then by defaultly it will take like latest as a version. If you use that in your production, then obviously in the upcoming like next tag, if you wanted to upload, if you don't give a tag name, then your old version will be gone. Okay, so there will be a break of your application. And these are the like commands for tagging, for docker tag and your like whatever the image name, and then tag. Okay, and this is like latest one. Okay, and this is your old one. Sorry, my bad, it is the old one. Okay, old or current one. Okay, and this is new one, my app v01, this is the new one, this is the old one. Okay, and if you see here docker build -t, whenever you are building, this is the format of giving a tag. Okay, and you are telling your command to check a docker file in the current parking directory like that. Okay, and moving to the next slide, here we are going to talk about registries and sharing. Okay, how exactly the image will be shared among the team. Okay, there will be kind of centralized registry, like how we use GitHub for source code versioning. Okay, likewise here image registry is also there. Okay, so we do have, if you see the flow, we do have a developer where they will build your images with the help of this command docker build -t, and they tagged the image name. Okay, and then there is a registry in between this. Okay, uh, basically this registries stores the images. So this is the command the docker, I mean, developer uses to push that into a registry, docker push, and then tag, and also username also they will use. I will discuss that also. And here if you see in the production, like a pull and runs. Okay, so like whatever the user or else whoever using in the production, they will just pull and run. Okay, so this is the command they will use, docker pull, and whatever the image like developer given, that is the one. Okay, they will pull from registry. Okay, developer gives to here, and they will give, I mean, fetches from registry. That is how the sequence of workflow will be done. Okay, and there is a registry types also, like docker hub, it is a one of the public registry. Free tier also available. And if you go with the cloud services, there is a AWS ECR, Amazon Elastic Cloud Registry, and Elastic Container Registry, and Google Container Registry. And also we do have one moment. Yeah, we do have Azure ACR, Azure Container Registry, and Harbor open source private registry. Okay, so these are like different registries, same like Docker Hub. Okay, will be stored in a cloud actually. Okay, we do have your account, and with the help of account, we are pushing that into our account cloud. Okay, and then with the help of same account we are pulling the image. Okay, and these are some essential commands for whenever you are working with registries. You need to first docker login. If you wanted to push also, you need to log in. If you wanted to pull also, you need to log in. And then you need to mm, a docker push. This is the command, like how exactly the developer does. This is the same command we are using. And then docker pull in the production environment, or wherever you wanted to run your container, that is where you need to pull the container. And then a docker search ubuntu. Basically this particular command will searches the, like, what are all the images which is available with ubuntu name. Okay, it will list all the images in your terminal itself. And also in the docker registry also, I mean docker registry in the sense docker hub, also you can search for the images. Okay, so, and then finally some practical examples and some interview tips. Okay, if you see, there is a let's say if you have a node.js application. Okay, so how exactly you will build that, how exactly you will do further process, let's discuss. Okay, first of all, if you have a node.js application developed, make sure to write a docker file. Later we are going to build a image with the help of this particular command. Okay, docker build -t, where it will tag a web app to v1.0 as a version. Okay, and then we run locally for testing. So this is the command to run locally for testing. So docker run -p, which is you are opening the port. That means your host port is 3000 and your container port is 3000. Okay, and then your application, image name and tag you need to give. And then if you use -d, then it will run in a backend mode. If you don't give -d, it will open in a terminal. If you can also see the, like, the request and response, everything like that. Okay, and this is the command to tag in your production. Okay, docker tag your image name, and then tag like your current image name and tag, and your username, and your like whatever the image name and tag. Okay, so basically it will tag to your username. Okay, and then you are going to push. Make sure whenever you are pushing, before that you need to tag like this. Okay, then you are going to push. Okay, basically this is your username, how the github has your username. Likewise docker hub has also have a username. And here are the, like, commands for image inspection. Let's say if you use the docker images, it will list all the images. Okay, whether it will be running or stop state, everything it will list. Docker history web app, let's say if you use this particular command, docker history and your image name and tag, basically it will show entire layers in the images. Okay, like what exactly it does and in which step it occupying the more space. Let's say if you like, you will build a docker file, right? So those all information you will see in this particular history command. Okay, so what exactly command it does. Okay, like that. And then the next command was docker inspect uh, web app. Okay, basically docker inspect web app, it will basically gives the detailed information about your image regarding like everything, mostly the service, regarding the network, regarding the volumes, everything, each and every detailed information mostly it will gives in a json file. Okay, dot json file. Okay, so that is the information you will get. And then moving to the interview, like some concepts, like you need to mostly focus on explain layers, immutability means what, and efficiency benefits within a clear manner, and some best practices, like what is multi-stage builds, and what is a dot docker ignore file, and what is minimal base image, and some security best practices by using what tags we need to use, like scan for vulnerabilities, root use a non-root user, and we need to optimize the like layer optimization, like size optimization, order commands by change the frequency, utilize the cache layer caching. Okay, and these are like some common questions you can expect. Difference between image and container, how do docker layer work, what what's wrong with the using a latest tag, what exactly happens in the background, what how to optimize a docker file for better performance, explain docker image security best practices. These are the some real-time scenario, like how exactly we can expect kind of questions. Okay, and I think we got a good understanding of the docker images, and yeah, stay tuned for more videos. Thank you.